Hello everyone, welcome to Ammu Simple Maths. This is R.Amuthvalli, your Maths teacher. Dear students, in today's session, let me start a new topic, a new chapter number 1. Yes, you're right, real numbers. Already you have studied real numbers and all the number system in your lower classes. Through this video, let me give a basic concepts. I'll make you to recall all the basic concepts in a jiffy. So you can recall and you can have a quick fix of all the real numbers and its basic concepts. Okay, what do you mean by real numbers? Real numbers consist of all rational and irrational numbers. So the real number system has many subsets. That is, under the rational numbers, you have natural numbers, whole numbers and integers. Okay, what do you mean by natural numbers? Natural numbers are the set of counting numbers which starts from 1, 2, 3 like that. These natural numbers are always denoted by capital letter N. Alphabet, English alphabet N. So natural numbers means all counting numbers, that is 1, 2, 3, etc. Then, what do you mean by whole numbers? Whole numbers are set of the numbers that include 0 plus to the set of natural numbers. If you include 0, if you add 0 to the set of natural numbers, then we get whole numbers. That means 0, 1, 2, 3, 4, etc. are called whole numbers. Okay. Then integers. Can we recall what do you mean by integers? An integer is a whole number. That means it is not a fractional number. That can be a positive integer or a negative integer or 0. So integer is a whole number that can be positive, negative or 0. Please go and watch the basic concept let us recall video, and also another video. I'll be giving the link in the description box. That will be more useful to recall all the basic concepts in a detailed manner. On the number line, how to recall the integers on the number line, I have given a very clear explanation. So you can watch that video also in addition to that. So integer is a whole number that can be positive, negative or 0, and it is denoted by the capital letter Z. So that means it can be minus 4, minus 3, minus 2, minus 1, 0, then plus 1, plus 2, plus 3, etc. Then next, what do you mean by rational numbers? Rational numbers are any number that can be expressed in the form of a by b, where a and b are the integers. That means integers mean that can be positive, negative or 0. But the denominator b should not be equal to 0. So from the rational numbers, actually we can understand that is derived from the term ratio. So ratio means it is in the form of a fraction. That is in the form of that is a by b, where a and b are the integers and b is not equal to 0. I hope you can understand this. So these rational numbers can always be expressed by using terminating decimals or repeating decimals. That means if they are rational numbers, when you divide the numerator by the denominator, you will get a decimal which has finite number of digits. Otherwise, for the rational numbers, you can get repeated decimals, non-terminating. It will not end up, but that will be getting repeated. So non-terminating and repeating decimals also yet another decimal expansion of the rational numbers. About this you have already studied in class 9. So please try to recall that also. Then next, now let us see few examples for this terminating decimals, that is repeating decimals, and the non-terminating decimals. Okay. First, terminating decimals are decimals that contain finite number of digits. So a few examples, 36.8, 0.125 and 4.5. Okay. Now let us see some few examples for repeating decimals. That means non-terminating but repeating decimals. 0.333. Here after 0 in the decimal place, the digit 3 is getting repeated. So non-terminating but repeating decimal expansion. And the next example, 7.689689. So 689, these 3 digits keep on repeating. Okay. Then what do you mean by non-terminating decimals? While expressing a fraction into a decimal by the division method, if the division process continues indefinitely and zero remainder is never obtained, then such a decimal is called non-terminating decimal. Or non-terminating decimal is a decimal that never repeats. For example, 0.076923 etc. So here no digit is getting repeated, and also the decimal expansion is going on. So the decimals never comes to an end. So the decimal, in the decimal place, the digits are infinite. We don't know where it will end. So they are called non-terminating and the non-repeating, non-terminating decimals. So they are the decimal expansions for the irrational numbers. This also you have studied in class 9. Next, I am going to teach you a very important theorem for this chapter 1, real numbers. That is nothing but the fundamental theorem of arithmetic. So under this fundamental theorem of arithmetic, what and all we are going to learn? Let me brief you. First one, what is fundamental theorem? The exact definition. What is the fundamental theorem of arithmetic? That I am going to teach you. Next, how to represent each composite number by its prime factorization with the knowledge of fundamental theorem of arithmetic. And third one is, what is the formula for computing HCF, that is highest common factor for 2 or 3 numbers by using fundamental theorem of arithmetic. So the formula. Next, how to find the LCM of 2 or 3 numbers with the knowledge, with the application of fundamental theorem of arithmetic. Then the last one is, what is the relationship between HCF and LCM and the product of 2 numbers? When the 2 numbers are given and any one, either HCF is given or LCM is given, how to find out? Suppose HCF is given, how to find the LCM? Suppose LCM is given and the 2 numbers are given, how to find the HCF? All these we are going to see under the fundamental theorem of arithmetic. Okay. What is fundamental theorem of arithmetic? See, every composite number can be expressed as a product of primes. This you all know. This representation is called the prime factorization of the number. This factorization is unique apart from the order in which the prime factors occur. Let me explain this with a very simple example. Shall we take one composite number? 10, a 2-digit composite number, say 10. What is the prime factorization for this 10? 10 ending with 0. So shall we divide by 5? So 10 divided by 5. 5 is the prime factor. So we have divided by 5 and you will be getting 2. So 10 can be represented as 5 into 2. So for composite number 10, the prime factorization is 5 into 2. This prime factorization for 10 is unique for that number 10 alone. So the order can be changed. That means there are 2 prime factors involved in composite number 10. This 10 can be written as either 5 into 2 or otherwise you can change the order as 2 into 5. But the prime factorization 5 into 2 belongs to one and only the number 10 alone. So we can say it is unique. We can't say 5 into 2 is 15. We can't say 5 into 2 is 21. So for 10, 5 into 2 is the prime factorization that is very much unique. So this is the core point of fundamental theorem of arithmetic. So you have understood, no? Okay. Now here is an example. See, let us take a composite number here, that is 1092. 1092, a 4-digit number. Since it is ending with 2, the last digit is 2, it is an even number. So we can divide it by 2. When you divide by 2, you will be getting 546. Again 546 is an even number, the last digit is 6. So we can divide by now you can either you can divide by 2 or 3. When you divide by 3, you are getting 182. Again 182 is an even number, so you can divide by 2. When you divide 182 divide by 2, you are getting 91. So 91 is ending with 1, but it is not divisible by 3 because 9 plus 1 10. 10 is not divisible by 3. So 91 it's not divisible. So for 5 no chance, 2 no chance, 3 no chance. So 2, 3, 5 no chance, all are ruled out. So the next prime number is 7. When 91 you divide by 7, 13 times. 7 13s are 91. So 13 is resulting the 13, that is also a prime number. So if you see in 1092 the prime factorization is 2 into 3 into 2 into 7 into 13. So the prime factor 2 is presented twice and the prime factor 3 is present for one time and 7 once and also number 13 also one time. So here when you are representing the prime factorization of 1092, you can change the order. You can change the order 2 into 2, that is 2 square into 3 into 7 into 13, or otherwise 13 into 7 into 3 into 2 square, like that. The order can be changed. The prime factors order can be changed in the product, but what are all the prime factors present in the composite number 1092 is very much unique to that number alone. This is what the explanation for fundamental theorem of arithmetic. So we can consolidate and we can summarize that the fundamental theorem of arithmetic is nothing but every composite number is expressed or factorized as the product of prime numbers, and this prime factorization, this factorization is very much unique. So this prime factorization is very much unique, and apart from the order in which the prime factors occur. So otherwise you can tell the prime factorization of a natural number, the prime factorization of a natural number is very much unique. So this is the fundamental theorem's definition. Exact definition of fundamental theorem is every composite number expressed or factorized as a product of prime numbers. This factorization is unique. I hope you can understand this. Now students, let me explain you how to find the highest common factor HCF and the lowest common multiple of any two positive integers by prime factorization method with the knowledge of fundamental theorem of arithmetic. Okay, I can brief you with an example. Find HCF and LCM of 108 and 150. Okay, how can you find the prime factorization of 108? 108, what is the last digit? 8. So let us divide by 2. So we will get 54. 54 is again an even number ending with 4. So let us divide by 2, you will get 27. 2 plus 7, 9. So it is divisible by 3. So let us divide by 3, you will get 9. 9 is very much divisible by 3. So 3 3s are 9. So 108 can be represented as 2 into 2 into 3 into 3 into 3. So with the help of fundamental theorem of arithmetic, we can write this prime factorization of 108 with the exponents of the prime factors. So that is 2 square into 3 cube, because 2 is present for 2 times, so 2 square. 3 is presented for 3 times, so 3 cube. So 108 can be written as 2 square into 3 cube. I hope you have understood this. Similarly, we will see what is the prime factorization of 150. 150 ending with 0, so let us divide by 5. So 35s are 150. Again 30 is ending with 0, so let us divide by 5. So you are getting 6. 6 is an even number, let us divide by 2. So you can divide by 2, you will get 3. So 150 can be written as 5 into 5 into 2 into 3. So with the knowledge of fundamental theorem of arithmetic, you can represent this as 150 equal to 2 to the power 1 into 3 to the power 1 into 5 square. Okay. What is the formula for finding the HCF? With the help of fundamental theorem of arithmetic, that is, product of smallest power of each common prime factor in the numbers. Okay, if you observe 108 and 150, so which are the common factors in that? Only 2 and 3. 5 is uncommon factor. So don't worry about the uncommon factor. So let us consider only the common factor. In the common factor, which is the least power, which is the smallest power, that you have to take. So if you take 2 square and 2 to the power 1, the smallest power is 1. So let us take 2 to the power 1, that is 2. And if you take the prime factor 3, if you compare 3 to the power 1 and 3 cube, 1 is the least power. So let us take 3 to the power 1, 3. So now let us find the product of these two numbers, that is the product of smallest power of each common prime factor in the numbers 108 and 150. So that gives you 2 into 3, that is nothing but 6. So the HCF of these two numbers is 6. Okay. Now let us pass on to LCM. So LCM the same way. See, what is the formula? Here the formula for finding LCM of these two positive integers is product of the greatest or the highest power of each common prime factor in the numbers. See, for us HCF, we have considered only the smallest power of each common prime factor. Here you see the word common is missing. Here we have to take the greatest or highest power of each common prime factor, not common, all the common prime factors, highest power you have to take and multiply and find out the product. Okay, now let us analyze the factors. If you see 108, that is 2 square into 3 cube, and 150 is 2 to the power 1 into 3 to the power 1 into 5 square. So if you take the prime factor 2, which is the highest power, 2 square. So let us take 2 square. And if you consider the prime factor 3, 3 cube and 3. Compare which is the highest, 3 cube. So let us take 3 cube. And 5 is the another prime factor present there. So that is 5 square. So the LCM can be calculated by the product of the greatest power of each common prime factor in the numbers. So that gives you 2 squared into 3 cube into 5 square. So 2 square is 4. 3 cube is that is 27. 27 into 4 is how much? 108. So 108 into 25 is 2700. So the LCM is 2700. Okay. Now here we can recall the relationship between HCF and LCM and the product of two numbers. That is nothing but HCF of the two numbers multiplied by LCM of the two numbers is equal to the product of the two numbers. Here, what are the two numbers given? 108 into 150. 108 into 150 if you multiply, the product is 16,200. How much? 16,200. You can take a paper and you can multiply and check the calculation. That is 16,200. And here HCF is 6. LCM is 2700 and 2700 multiplied by 6 also gives you 16,200. So hence, so we have verified that HCF and LCM of the two numbers 108 and 150 is equal to the product of 108 into 150, that is nothing but 16,200. I hope you have understood this. So we can summarize the formula. What is the highest common factor and what is the least or lowest common multiple by using fundamental theorem of arithmetic. So the HCF of two numbers is equal to the product of the terms containing the least power, that is smallest powers of common prime factors of the two numbers. And what is LCM? The LCM of two numbers is equal to the product of the terms containing the greatest powers, highest powers of all prime factors of the two numbers. So these two definitions you have to learn by heart. Okay. Now let us recall the relationship between HCF and LCM with another example. That is, for any two positive integers, say A and B, HCF of A and B multiplied by LCM of A and B is equal to A into B. Okay. Now let us take very small example. If A equal to 3 and B equal to 6, both are positive integers. See, 3 and 6. In 3's table, 6 is coming. 3 1s are 3, 3 2s are 6. So here the smallest number 3 is the HCF and 6 is the multiple of 3. So 6 is LCM. Okay. now shall we multiply HCF and LCM? 6 into 3. 3 into 6, that gives you 18. So what are the two numbers given? A into B, that also 3 into 6. So you are getting 18. So HCF and LCM of the two numbers 3 into 6 equal to 18, and the product of the two numbers 3 into 6 also 18. So the relationship between HCF and LCM is verified. Okay, now we'll take another example, 26 and 91. What is the prime factorization of 26? 2 into 13. And what is the prime factorization of 91? 7 into 13. So highest common factor, that is HCF is 13 is the only common factor. So that the power is 1, so that is 13, and LCM is here common factor and uncommon factor, all the powers, highest power if you take 2 and 7 and 13 are there. So if you multiply all these 13 into 2 into 7, you will get the product 26 into 7, that is 182. Okay, now let us find out what is the product of LCM and HCF. LCM is 182, HCF is 13. It gives you the product 2366, 2366. Okay, now let us find out the product of the two numbers, that is 26 into 91. So that also will be equal to 2366. Hence LCM into HCF equal to the product of the numbers is also verified. Okay, as a final thing, I am going to give a question to find out. So it's a task for you. So try to find out, students. Given that for two numbers 306 and 657, the HCF is 9. You find the LCM of 306 and 657. See, when the two numbers are given and HCF is given, LCM can be found out by which formula? That is nothing but, you already know HCF and LCM equal to A into B. Here HCF is given. So LCM is A into B divided by HCF. So here A into B is, A is 306, B is 657. So 306 into 657 divided by 9. Okay, 306, 3 plus 0 plus 6 is 9. So it is divisible by 9. So let us cancel 9 and 306. You will be getting 34. So in the numerator, 34 into 657. If you find the product 657 into 34, you will get the LCM is 22,338. So please take a paper and work out this sum, and please tell me whether it is easy for you. Can you able to understand? Students, I hope this video is very much useful to you. Please watch twice or thrice, and please try to understand all the concepts. And if you have any doubt, you can post your doubts and also your feedback in the comment section. Thank you. Thank you, students.